The moon, our celestial neighbor, has long captivated humanity's imagination. From ancient myths to science fiction, it has held a special place in our collective consciousness. In recent years, the dream of establishing a permanent human presence on the moon has been rekindled. Governments and private companies alike are investing heavily in lunar missions, signaling a renewed era of lunar exploration. This time, the goal is not just to visit, but to stay. The 21st century has witnessed a surge in lunar missions, with various nations and private enterprises setting their sights on Earth's natural satellite. These missions aim to map the lunar surface, analyze its composition, and identify potential resources. The moon's proximity to Earth, coupled with its unique geological features, makes it an ideal location for scientific research and a potential springboard for deeper space exploration. The establishment of a permanent lunar base would mark a significant milestone in human history. The moon is rich in resources, including helium-3, a potential fuel for future fusion reactors, and rare earth elements crucial for advanced electronics. Mining these resources could have significant economic benefits and reduce our reliance on terrestrial resources. The potential for scientific discovery on the moon is vast and remains largely untapped. The initial phase of establishing a lunar society involves sending astronauts and essential supplies to the moon. This requires powerful rockets capable of carrying heavy payloads and advanced spacecraft designed for long-duration space travel. The journey to the moon, although relatively short, still presents significant challenges. Astronauts must endure the rigors of space travel, including exposure to radiation and the effects of microgravity. The first missions will focus on establishing a basic outpost, a temporary habitat where astronauts can live and work for extended periods. Robotic missions will precede crewed missions, mapping the terrain, identifying suitable landing sites, and delivering essential equipment and supplies. Landing on the moon requires precision and expertise. Once on the moon, astronauts will begin the task of setting up the initial habitat, deploying solar panels for power, and establishing communication links with Earth. The initial crew will consist of highly trained astronauts, engineers, and scientists. They will be responsible for conducting scientific experiments, exploring the surrounding area, and collecting valuable data. These pioneers will be the first to experience the unique challenges and rewards of living and working on another celestial body. Creating a safe and sustainable habitat is paramount for long-term lunar habitation. The lunar environment is harsh and unforgiving, with extreme temperature fluctuations, radiation exposure, and the constant threat of micrometeoroid impacts. Initial habitats may be prefabricated modules transported from Earth, while later structures could utilize lunar regolith for construction. Infrastructure development will be a key focus in the early stages of lunar colonization. This includes constructing power generation systems, communication networks, and transportation infrastructure. Solar panels will likely be the primary source of energy, supplemented by other renewable sources or potentially nuclear fission reactors. Reliable communication links with Earth are essential for coordinating missions, transmitting data, and maintaining contact with the outside world. The habitat will need to be pressurized and equipped with life support systems to maintain a breathable atmosphere and regulate temperature. Recycling systems will be essential for conserving resources and minimizing waste. Water will be a precious commodity, potentially extracted from lunar ice deposits or recycled from human waste. The moon base will gradually evolve from a small outpost to a self-sustaining settlement, capable of providing for the needs of its inhabitants. Water is essential for human survival and will be a critical resource on the moon. While some water may be extracted from lunar ice deposits, recycling and conservation will be crucial. Water recycling systems will purify wastewater and recover moisture from the air, minimizing the need to transport water from Earth. Food production will be another key challenge. Initially, food will be transported from Earth, but long-term sustainability requires establishing lunar agriculture. Hydroponic systems, which grow plants in nutrient-rich water without soil, offer a promising solution. Power generation will be crucial for powering the lunar base. Solar panels will be the primary source of energy, harnessing the abundant sunlight on the lunar surface. Energy storage systems, such as batteries or flywheels, will be needed to provide power during the lunar night. The efficient management of these essential resources will be vital for the survival and prosperity of the lunar society. Creating a breathable atmosphere within the lunar habitat is essential for human survival. The lunar atmosphere is extremely thin and lacks oxygen. The habitat must be pressurized and equipped with systems to generate and maintain a breathable air mixture. Electrolysis, a process that splits water into oxygen and hydrogen, could be used to generate oxygen. Plants within the habitat will also contribute to oxygen production and carbon dioxide removal. Radiation shielding is another critical aspect of life support. The moon lacks a global magnetic field and a substantial atmosphere, leaving it exposed to harmful solar and cosmic radiation. The habitat must provide adequate shielding to protect the inhabitants from these harmful rays. Maintaining a stable temperature within the lunar habitat is also crucial. The lunar surface experiences extreme temperature fluctuations between day and night. Medical facilities will be essential for addressing any health issues that may arise. Establishing a reliable food source on the moon will be crucial for long-term sustainability. Hydroponic systems, which grow plants in nutrient-rich water without soil, offer a promising approach. These systems can be established within the controlled environment of the habitat, providing a source of fresh produce. LED lighting systems will mimic sunlight, enabling plant growth even during the lunar night. As the lunar base expands, greenhouses could be constructed, offering larger-scale food production. Lunar regolith, the loose surface material, could be used as a growing medium, supplemented with nutrients and organic matter. Research into specialized lunar crops will be essential. Scientists will need to identify plant species that are well suited to the lunar environment and can thrive in lunar regolith. The integration of aquaculture, the farming of aquatic organisms, could further enhance food production on the moon. This synergistic approach can maximize resource efficiency and enhance food security. As the lunar base grows, it will transition from a small outpost to a larger, more complex settlement. This will involve constructing additional habitats, expanding infrastructure, and establishing specialized facilities. Modular construction techniques will allow for flexible and expandable living spaces, accommodating a growing lunar population. 3D printing technologies could utilize lunar regolith to create building materials, reducing the need to transport materials from Earth. The development of a lunar transportation network will be essential for connecting different parts of the settlement and facilitating resource transportation. Lunar rovers will be used for short-distance travel, while a lunar railway system could be constructed for transporting larger quantities of materials and people over longer distances. Establishing specialized facilities such as research laboratories, manufacturing plants, and medical centers will be essential for supporting a diverse and thriving lunar society. Research laboratories will focus on lunar science, resource utilization, and advanced technologies. The development of recreational facilities and cultural centers will be important for the well-being of the lunar inhabitants. Creating opportunities for leisure, entertainment, and cultural expression will enhance the quality of life and foster a sense of community. The moon's rich resources offer the potential for a thriving lunar economy. Helium-3, a rare isotope of helium found in lunar regolith, could be a valuable fuel for future fusion reactors. Mining and processing helium-3 could provide a significant economic opportunity and contribute to solving Earth's energy challenges. Rare earth elements, crucial for advanced electronics, are also abundant on the moon. Lunar tourism could become a significant industry, offering unique experiences to adventurous travelers. Visitors could explore the lunar surface, visit historical landing sites, and experience the thrill of low gravity. The moon could also serve as a hub for space-based manufacturing and assembly. The low-gravity environment and access to lunar resources could make it an ideal location for constructing large-scale space structures. Trade between Earth and the moon will be essential for the lunar economy. The development of efficient and reliable transportation systems between Earth and the moon will be crucial for facilitating trade and supporting the lunar economy.